So there are a lot of notes to go with this second quiz, proportion applications. It's going to start with similar figures, then we're going to talk about word problems, and then we're going to end with something called the factor label method, which is what you need to know how to do to get an A++. Takes a little getting used to. I think it's pretty cool, but you know, that means nothing probably to you. So similar figures, all we're really talking about are shapes that are the same shape but a different size. So in every respect, they're the same except for their size. Boom, boom. Two triangles that are similar, they're basically the same triangle, but one's just been blown up a little bit more. So all the corresponding angles are the same and the sides are proportional, and that's the key. They're proportional. And if you don't remember from the last set of notes, proportional means equal ratios, and that's the word. I'm pointing at something. And this is symbol for congruent, remember? Meaning that if that's 90, that's 90, that's 60, that's 60, this is 30, this is 30. So the corresponding angles are the same. So really what's going to happen is I'm going to give you these shapes and say, hey, these are similar. What is x? Or another way of saying that is what should x be to make these similar? And what you're going to do is write a proportion for each one. So for basically this whole chapter, this whole section, it's all about just writing a proportion, which if you remember is basically just a fraction equal to a fraction. And so another way of doing it, if you're lucky, was to look for that common multiple. So I've noticed, especially because I wrote this problem, that 3 times 2 is 6. So that means if this is similar, that also has to be times 2, and I know x is 10. And that's it. Boom. X is 10. Easy. Another way you could have done it. And I like to label things. When I say LB, I'm saying the left side of the big triangle is x, right? So that's the left side of the big triangle. It's x over the bottom of the big triangle. That's 6. So you're always trying to do two things when you're doing proportional problems. One, you're making comparisons that make sense. So I'm just comparing the left side to the bottom side. And you've always got to make sure things are in the right order. So that's why I have my equal sign. Then I said the left side of the small triangle. So see how in this fraction it went left over bottom? That means on the next fraction also has to be left over bottom. And then we would cross multiply and solve and get x equals 10. In case you have forgotten what I mean by cross multiply and solve. Remember, you're gonna, whoa, that's way too weird. Boom. And you would have gotten 3x. And if you went this way, you would have gotten equals 30. And then you would have divided both sides by 3. And that's why you got 10. Oh, wow. I'm very bad at drawing in Photoshop. Now, the thing is, you don't always have to put things in that order. Some people compare things like their heads work a little bit differently. And they see their comparisons different. So maybe I compared the left of the big side to the bottom of the big side. Somebody else might be thinking the left of the big triangle compared to the right, the left of the small triangle. And so they write their fraction differently. And then they say, well, the bottom of the bottom. And in this case, you say it was LB over BB, LS over BS. So it's basically left over bottom, left over bottom. On this one, it's going to be big over small, B over S, equals to B over S. And if we cross multiply on that one, that was weird. We're going to get the same answer. It's going to be 3x equals 30, x equals 10. So all I'm saying is all of you might not have the same fractions, but you can get the same answer. So maybe somebody on this one says x is compared to 6, as 3 is compared to 5. That's what this says. And if you look, they said I have L over B, but in this one they had B over L, meaning they have flipped those, meaning that is a wrong answer. Okay, so just make sure you're keeping things in the same order. That's really all we're doing for this section, is we're just writing a bunch of proportions. This question, it's the same thing, right? You want to try to solve. What a lot of people might do, though, is they'll say, okay, well, it's, x over 6, because it's x and 6, and then they could say 4 over 6. 4 over 6. If we cross multiply this, we get bloop 24, bloop 6x. We would solve it by dividing by 6. I've got to talk faster. And we get x equals 4. And you're like, cool, x is 4. However, that should make no sense in your head at all, because 6 is this side, 4 is this side, and x is definitely larger than 6, so how could it be 4? This is a trick question in that, I've taken that second rectangle and I put it on its side instead of having it upwards like that one. So what I've tried to do is trick you into being like putting the wrong thing. That's why it's good to label. So, which is why I have LB over SB. So x over 6, which, I don't know, I put L. I'm thinking it should have just been the long side. Okay, that's right. Long side of the big rectangle over the small side of the big rectangle equals the long side of the small rectangle over the small side of the small rectangle. So it's the, oh, I can't write on stuff. Okay. So right here, I'm saying long, no, still things are invisible. Oh, there you go. When I say LB, I'm saying long side of the big rectangle over the small side. That's why it's x over 6 equals the long side of the small rectangle. That's LS6 over the small side of the small rectangle. And then when you cross multiply, you get x equals 9, which makes more sense. Okay, you might have a weird looking triangle that looks like this, but this is just as simple. You're literally just thinking of this as two different triangles, and there's a long way to do this, but just so you know, if these are parallel, which means it has those, those marks, you can just set this up as an easy set of fractions, proportions. X over 2 equals 5 over 3. So it's really just the long side over the small side equals the long side over the small side. And so then you cross multiply. And you get 3x. 3x equals 10. You get x equals 3.33. But like I said, you don't have to have the same proportions all the time. So x over 5 equals 2 over 3 is equally valid because it's still keeping things in the same order, and you're comparing. You're comparing the biggest side of the bottom to the biggest side of the top, so equals the small side of the bottom over the small side of the top. So you can get 3.33 again. Some people would have done 3 over 5 equals 2 over x because it's small over big on the top equals to small over big on the bottom. You get the same answer. Then this one is wrong because they're saying x is compared to 3. And you can't compare those together because they don't really match up at all. So you can't compare the big side of the bottom to the small side of the top. That doesn't work, which is why you get a wrong answer. Okay. Let's talk about word problems, and I forgot I was going to show you. Basically, proportional shapes happen a lot. this is Keelik playing basketball last year. When you're trying to make things the same, when you just try and change the size, right? So what happens is, if I'm trying to resize Keelik and I don't do it properly, you can tell suddenly he's skinny when he was, well, okay, he's always kind of skinny, but he's skinnier than he should be. Or if I'm like, this is too big, I want to make it smaller, suddenly he gets kind of thick. So keeping things in proportion is important because you can tell when you don't that the size isn't right. Okay, I need to change things really quickly, so hold on a second. Okay, so I'm just changing to something else. I don't know actually if you'll be able to hear what they're saying,
5 feet long, 8 feet wide,
but
it weighs 24,000 pounds.
What's happening is they're trying to
do is scale that bus down for our small scale test. What I have here is a toy bus. Now this isn't going to work. So what I need to do is make a 1/12 scale bus that's remotely controlled and has the right weight distribution.
So they're talking about making a scale, which is literally they're making a proportion, making it smaller to try to make it correct in every way. The weight,
While they scale
everything.
The bus, I'm scaling the course.
And she's
Now,
scaling the
this
course.
gap is 50 feet, so we've got that covered. But just as important is the angle of the road. And we've calculated it to be 1.2 degrees with the exit ramp 2 feet higher than the landing ramp. All of which will be scaled perfectly for this experiment.
So when they say scaled perfectly, when she had her little part, it wasn't 50 feet. They calculated exactly how many feet it would be. I don't know if you hear her talk or not when that happens. And then, it's not going to be it'll be a 1.2 angle because that has to stay the same. So they're scaling everything, which a scale means they're keeping it proportional. So everything is being shrunk exactly correctly. And I don't know what just happened there. That was creepy.
There is no way that bus is going
Right.
to make it across that gap.
And they're trying to make it
Done saying
jump.
last goodbyes?
Unfortunately,
What's gonna happen
in
is
this
it's gonna
clip,
crash on the ground and we're gonna have to
we don't actually get to see it happen. So you'll have to watch the actual video to see what happens. So now I'm going to switch back to Photoshop and back to Keelik. So next set of notes. Like I said, it's kind of a long set. This is just another example of what we just did. Basically, these are parallel, so you can just set up some different proportions. X over 7 equals 6 over 4, which is bottom right compared to bottom left, which equals to top right over top left, because that's right over left equals right over left. You get 10.5. But there's also, you could have done 4 over 7 equals 6 over x. You could have done 6 over x equals 4 over 7. You could have done 7 over 4 equals x over 6. You could have done 4 over 6 equals 7 over x. You'd get the same answer for all of those. And then these two questions, it's kind of a trick. And what happens is, since that's 6 and that's 6, right? And that's 8 and that's 8. So this line, which is parallel to the bottom, is cutting this triangle exactly in half, right? Because this part from this part is 6, and the whole thing, 6 plus 6 is 12. This is 8, and the whole thing is 16. And so if this line is parallel, and it cuts the triangle in half, that middle line is always exactly half of the bottom. So if it cuts it in half, it's going to be half. So just, I can do the same thing except for the tick marks. Equal, 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 oh, congruent, 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 congruent. Parallel, parallel. So this line is exactly half of the bottom, and 9 is half of 18. And that is the first set of notes. That's similar figures. I'm going to do a new video for word problems and the next parts. I think on my YouTube I'm only allowed to talk for less than 15 minutes. So, okay, there'll be another one.